All right, welcome. So I will be talking today about object-oriented JavaScript, obviously, I think. Occasionally during this video, I'm going to look over here. This is where my guide is, so don't, if I'm looking over here, don't think I'm watching a football game or something. That's just where my script is. Anyhow, to get right into it, one thing I want to mention before we start, I'm going to be doing a lot of examples, more examples than just reading from slides, because I don't think the slides convey it. It's kind of a confusing topic. We'll get into it. I think a lot of people are confused about it. Most people have a vague understanding of how object-oriented programming works in JavaScript. They've generally heard of prototypes, but whatever. We'll get to it. It'll be much more clear as we go on. And I'll try to incorporate some of the concepts that we're learning in our class to maybe some design patterns, things like that, to see how it might translate into JavaScript. So let's see here. So JavaScript uses prototypal inheritance, and again, I'm going to try to avoid reading directly from the slides because there's not a lot of content in the text, so hopefully I can just speak it. But it uses prototypal inheritance, and what exactly does that mean? Well, I guess in another form, it doesn't strictly use classical inheritance as you are familiar with. It doesn't have the notion that there is this class, which you could think of as some kind of factoring, I don't mean the design pattern, but some kind of construct that produces these objects, and the relationships between parents and children are through the class hierarchy. It's totally different. There is a prototype that is attached to every object, and that is sort of passed through, or it creates a prototype chain, rather. It's easier to just describe it like that. And JavaScript has no classes. And by that I mean no classes as we understand the term classes. It has classes, it has a notion of classes, and there's a way to define a class in JavaScript. There's even a new class keyword in ES6. But the class as we understand it is, again, some sort of abstract thing that produces things. You can mimic it, but there's no direct correlation. So to continue, what is a prototype? So JavaScript has certain primitives, numbers and strings. If it's not a primitive, it's an object, and everything is an object. And then there's certain special objects like functions, and every single object has a prototype on it. So in like the big object has things like toString on it, right? Like the default functions that you want to be a part of every object that you ever instantiate. And you can override them, which I'll show you later, to create your own toString functions and everything. But there's a certain default set of functionality included with every object that you make. And that includes functions as well. And functions have their own set of prototypical behavior. So they have things like call and apply, if you're familiar with JavaScript at all. Those are part of the function prototype. And the way, ultimately, that these prototypes interact with one another is if you were to make, say, a subclass of a parent class, if you tried to access a property on that subclass, and it wasn't found on the subclass, it would check the prototype chain, so it would look at its own prototype and see if the property that you were trying to reference was on that, and it would continue to ascend the prototype chain until it ran out of places to go. So again, if you said call toString on some new object that you created, and you hadn't created a toString function of your own, it would look into the prototype, it would find that there is the object's version of toString, and it would use that instead. So when a property is referenced, as I mentioned on the slide, if it's not immediately found, each successive member of the prototype chain is referenced. And I'll show you this in an example so it's very, very clear. So why are there no classes? Well, Brendan Eich is the guy who created JavaScript, and I was trying to get a good, straight from the horse's mouth as to why he used prototypal inheritance as a model. And from what I could tell, there's more information about why certain constructs look like some of our classical inheritance models, and less about why he strictly used prototypal inheritance. And it's interesting because prototypal inheritance turns out to be considerably more flexible, or it allows for a lot of really interesting things that would be much more difficult to do in a classical inheritance pattern. And likewise, prototypal inheritance can mimic classical inheritance fairly easily, which you'll see. And yeah, I'll get to that in a coming slide and in the examples. But basically, as the slide mentions, when JavaScript was first being developed, the object-oriented paradigm was huge. Java and C++ were these languages that lots of people were trying to use, and they had a lot of familiarity with. And so certain elements of those languages were brought into JavaScript to try to familiarize people with the new utilities that they would be able to access using JavaScript. That being said, they are there in some ways as a mask to a different type of functionality. So it was to give programmers new to the language a certain amount of familiarity with something that they had never used before. So instead, they just sort of papered over the things that might be difficult for them to understand at first and just use things that they're familiar with. So for instance, the new keyword exists in JavaScript, but it's not what you would necessarily expect it to be, or it works sort of the way that you want it to, but it comes with a caveat. It comes with many caveats, and honestly, you may not even want to use it, but we'll get to that also as we get to the examples, so you can just see. And here we have already talked about the fact that everything is an object, so that is all about the primitives, etc. Or, sorry, all about having a prototype as part of it. So, despite having things like a new keyword and making it seem like you're about to instantiate a class, the new keyword doesn't do that. And instead, everything that you add to a prototype is essentially an extension of an object. It just uses it uses composition instead of inheritance. Now, inheritance, yes, it definitely takes things from something else, but you're essentially plugging them onto an existing object's prototype. So, in a similar way, or rather, objects inherit the prototype from something else, and that something else is not a class, it is already an existing object in the namespace, or just in the program somewhere. So you're not taking it from some sort of abstract concept. You're taking it directly from another existing object. So if you make changes to that existing object, those changes will be reflected in the child that you are plugging your prototype into, which is extremely powerful. As I'll show you in some of our design patterns examples later, it makes doing things like changing things at runtime very simple. It means that you can just add a function to the prototype whenever you want to, and all of the children will have it. You don't have to create special extra classes to handle how we're going to modify each piece at the lower level. Everything just sort of handles itself. It automatically, since it's an object reference, once you make a change to the object that the prototype object, once you make a change to the prototype object, all the subsequent children that inherit from that prototype object inherit those changes as well. So I just want to mention real quick I'm not going to show you examples of this later, but, and I did already mention it previously, there's in ES6, ECMAScript 6, that's was just approved and finalized in June or July. They introduced a new class keyword, which makes it even easier, you could say, to mimic classical inheritance patterns using, basically, it looks almost just like the Java that we've been doing in class. You define a class, you can call super, you have a constructor. It's very, very clear. But all that is doing, again, is sort of papering over what's happening underneath. And it's all syntactic sugar to hide the details of what's going on. But you can currently make that same kind of classical inheritance relationship without needing a class keyword or anything. And I'll show you how to do that. So I believe we're at the example phase. So I think animals are the perfect way to illustrate any kind of object-oriented programming because, I don't know, there's so much variety, and there's genuses and species and subspecies and who knows what. So, just to give you a simple example of how an animal class would work, this is our animal. And this is our constructor, which is a little odd, because if you know JavaScript, you know what we've just created is sort of a function reference, and we've given it some properties, but it doesn't look quite like a class, maybe that we're familiar with in other languages. But as you go on, maybe you'll see some more familiarities. So, after that, we define on animal prototype a make noise function, okay? And then we instantiate an animal with the new keyword, which again, we don't necessarily need to do this. We could call animal outright, but we'll get into the new keyword and how it comes into play a little bit later. But then you can call animal make noise, and this is functionally what we're doing. So we have this animal, animal1. I can change that here. We give it a name, Rover, Felix, and then we have this prototype, which is carried with all animals, and it's going to have make noise as a function, and it's going to call that function. So let's just see what this does. And again, this is just sort of this is the simplest example just to sort of show you what it looks like when we make the parent class. So, as to be expected, when these animals speak, they say their names, and pretty simple. Okay, so moving on. So, now we have the animal again. Here's its make noise, and we have them here. And now we've decided to subclass it. So let's make a dog, for instance. So what are we doing here? So here's, again, our constructor, dog. Takes in two parameters, the name and the breed. And the first thing it does is it calls animal, well, it calls animal. Sorry, I gestured to my screen. I know you can't see that. I'll use the mouse instead. It calls animal with this and the name. So what is that doing? Well, this is similar to doing a super call in Java. It's just calling the parent class's constructor, as it were. And this, in this case, is passing in the context of this dog. So if you're not familiar with this in JavaScript, that is a topic unto itself. And it is extensive, and it's one of the most confusing parts about JavaScript. But all you really need to know is that if we didn't call this here, it would use this up here. Well, it would use the this relating to the animal function, not the this relating to the dog function. So we call it using this so that animal essentially keeps in mind the dog that we are referring to. We use name here to specify that this is the name of the dog, whatever. It's going to assign itself to the name that the animal uses, and we're going to assign the breed, whatever. This is its own. This is the variables associated with the dog. They get their breed. So then we assign the dog's prototype to animal prototype, and we use object.create. Now, this is a special feature introduced in ES5 that does basically, you kind of probably would want to just assign it directly to animal.prototype, but that's just not how you do it. To save time without going into it too deeply, and I could probably go considerably deeply, well, we'll get to it more in the future. This is just how you assign dog's prototype to be the prototype from animal. So it will include make noise, and then we have to assign the constructor of the prototype to dog. Now, this is something that's a little controversial, or depending on who you talk to, you don't need to do it this way. This is the classical inheritance pattern, and if you choose a much more strict prototypal inheritance, you don't need to do this at all. You would just use a chain of object.creates to induce the chain that you're trying to create of animal.prototype and then subclass and subclass however many times you'd like to. If you assign the constructor to dog, what that does is essentially allow you to use the new keyword later and also allow you to use instance of correctly, which instance of, incidentally, checks the constructor property of the prototype. So if you don't set this, it's going to be set to the prototype that you passed in. So it would likely be an animal, and the instance of might not work for dog. It's all a little convoluted, and again, it's so that you can use things like instance of, which you may or may not ever need to use. In the instance that you do need to use them, this is how you do it. So here we have dog.prototype.makeNoise. We've overridden the makeNoise function from animal with our own. So I bark like a normal dog, etc., etc. We also have added to the prototype is fancy. So we'll see what that does when we run the program. I'm sure you can kind of read it right now. We instantiate a new dog. We call the makeNoise function and the isFancy function. And we're going to see when we run the program that dog is indeed an animal and is indeed a dog. And also, why not make another child class, subclass of animal called cat, give it a name as well, and a property about liking milk, whether or not it likes milk. Same situation here. We're going to create the object.create animal.prototype onto the prototype. And again, reroute the constructor so that it points to cat. And we're going to write a will drink milk function. And if it likes milk, we'll print something. And if it doesn't, we'll print something else. We'll create a new cat. We'll call the makeNoise function, which we, again, this time, did not override. And we will call the will drink milk function. So we have a cat prototype, we have a dog prototype, we have an animal prototype. The animal prototype is attached to the dog prototype and the cat prototype. So what's going to happen? It's all going to work right. I've tested this, just so you know. You might think that maybe, I don't know, since we're messing with the prototypes here, we're adding an isFancy, and it's maybe is it pointing to this animal.prototype? Is this going to have isFancy too? Is making, overwriting makeNoise here going to make the cat bark? Let's see. Well, no, it looks like it worked perfectly right. We had these two animals at the beginning. They are doing their thing, making noise. The dog barks, as expected. They're not fancy, just an old husky. And these two truths are indicative that the dog is an instance of an animal, and it is an instance of a dog as well. And the cat uses the make noise supplied by the animal, since we didn't override it, and it obviously will drink milk because cats love milk. I think that is a common stereotype of cats. Can't blame them. Looks pretty good. Okay, so that would be with two subclasses, two separate subclasses. So I want to show you the same process with a third child, a grandchild of the animal class. So we don't have to go over this anymore. Here we have our classic animal stuff. Now we have dog. In this case, I changed. Prior to this, we were using breed on the dog. We don't want breed there anymore, but dogs generally have a color. And the breeds themselves will be the grandchildren, the subclasses of what a dog is. So I chose to put a default here so you could see what it's like, so we don't have to get essentially an extending string of parameters on all the subclasses. You know, you could have every subclass essentially call up the super with a longer and longer, just filling all of the conditions of each of the constructors, making sure you have the parameters for each one. But in this case, for dog, it's got an optional parameter in color. So if you provide the color, it will assign the color. If not, it will just default the color to white. So we'll see what that does later. Again, we've overridden the make noise function. This time we've adjusted the fancy function just since we don't have the breed anymore. And now we've created a grandchild class of animal, a subclass of dog called a husky. And here we have it calling the superclass with just the name. So we didn't provide a color. So the color in this case will be default. So presumably the white color. The breed will be husky. And we again assign the dog prototype to the husky prototype and the constructor so that we can use a new keyword when making this husky. And here we have an example of making a dog. Here we have an example of making a husky. And now we have an opportunity to see if that husky is all three, an animal, a dog, and a husky. So let's see if this works. Indeed it is. This animal is a dog and a husky. That's fantastic. All right. So the power in this lies in the fact that we can do anything we want at runtime with these objects. So I mentioned it earlier. If we want to adjust the prototype of the animal at some point in order to give new functionality to the subclasses, we can do that. So if something changes in the future and we want, or whether that future is way down the line and we're not running the program, or it's while the program is running and we need to adjust something on the fly, we can adjust the animal prototype and all of its children will suddenly inherit all of the properties. And the reason that this is because the prototype is not, it's not a reference to a class or some abstract thing that we're using as a template to create new things. It is an object that lives in memory already. And so these subclasses, the children, they have pointers to this object in memory. And so when that object changes, they don't have to do anything. They're still pointing to that object. And now that object has a new property on it, and we can access that property when we need it. So here we have same animal code as usual. We have a dog, same stuff, same husky stuff. And then at some point we decide that we want to add an eat function to the prototype. So animals can eat in general, so that's not surprising. So once we add it to the prototype, now we can just use it. So dog1.eat and husky1.eat, these are our dog and husky references. Let's see what happens when we run this program. And so they just eat, just like that. We didn't do anything. We didn't have to change the dog code or the husky code. We just added something to the prototype. And now they have totally new functionality that they didn't have before. And So this can work with our design patterns that we have been working on in class and testing out. We have a lot of different design patterns that rely on changes at runtime. So here is the strategy pattern, for instance. So we have a dog, same general stuff as before. Animal inherits from dog. Dogs can make noise. And then at some time in the future, we want to say that the dog was cornered, right? So based on some event, right now I'm just having some random number generate this. We're going to make the cornered property on the animal prototype be fight, and if it was different, if the strategy was greater than 5, or some sort of occurrence happened, a different event happened, however you want to handle it, we're going to make the cornered function be something different. They're going to flee. They're not going to fight. They're going to flee instead. And then we're going to call dog1.cornered. I mean, the power of this is tremendous. At runtime, we can just add any new functionality. Not only that, we can choose which functionality we want based on something else that's happened. So we can add new properties. Not just can we add new properties, we can conditionally add new properties. We can compose the objects. We can create a strategy pattern for these objects, adjust them at runtime, and all of the objects that inherit will get that strategy, or anything. I mean, we can make it at the subclass level, we can make it at the parent level, we can put it anywhere in the prototype chain. So let's see. Okay, they fleed that time, fleed, fought. So you can see, it just depends on what happens. Based on the roll of the die, where you clicked your button. And so in all of these cases so far, I showed you what would happen if you, say, added a new function to the object. But it's not limited to just functions. So again, here we have an animal and a dog that inherits from animal. And suppose we decided that we wanted to have a more complex object to fit into, to comprise, or to compose the dog. We wanted to have a sub-object within the dog, some sort of compositional element that provided new capability beyond just being able to run some single function, but you could have a extremely complex object. And so in this case, the object that I'm supplying is not extremely complex, but by the nature of JavaScript, you can make this object as complex as you'd like. In this case, we have a relatively simple 3-property object, but this could be an object that had sub-objects and sub-objects within them that all had their own prototypical chains of inheritance going down and down, farther and farther. And so we have this vision system here that we're going to apply to a dog. So we're going to add to the prototype eyes this vision system. It's got a number of eyes, and it's going to have a see function and a blink function. Again, this could be an unlimited number of objects. Well, limited by memory and things like that. But you can extend this as many ways as you'd like. You could make extremely complex objects and just plug them in to your dog. And now, without having ever messed with dogs now have eyes, and they can see, and they can blink, because we added the vision system to the animal prototype. Now anything that inherits from animal will have eyes as well. And let's just see this work. So you can see there's tremendous amount of power in this system. This all looks somewhat similar to what we've come to recognize from our classical inheritance in Java and C# and C++ to a degree. Uses new keyword, there are constructors. You can see that here. They can be more explicit elsewhere, but it has the same ideas, but the prototype chain is totally different. It's this totally separate idea about having objects inherit from objects. And what you can get through that pattern is runtime manipulation that is so powerful that you can change anything you want whenever you want to, which sounds dangerous. But you can do all the same kind of things that you can do in classical inheritance. You can have private variables, you can have strong encapsulation. You can maintain all of the things all the solid principles that we so desperately need. But it does so in a way where everything seems much more compositional. So one of the main flaws sort of in classical inheritance and what the Gang 4 stresses is that you should favor composition over inheritance when possible, because inheritance is a strong, it maintains strong links between the parent and the child. They can't really be separated easily. They are highly coupled. But with all this compositional stuff, we can take things out, plug things in at runtime whenever we want to. We can create objects that are considerably more complex with a single condition. And it's very, very powerful. And that's really all I got for you. So I hope this illuminated some stuff about how this all works. It obviously is a little bit, the examples may have been a little bit trivial. It's not like I built a database or something for you to see how I use animals, but I think it's pretty clear from these examples generally how the prototype chain works and the implications that it presents. So thank you very much.